Hey everybody, so you asked for a review of a video to go over question number 92. Um, and this was where we were trying to find a limit as delta, should be delta x here. Let me put that delta x here, in this case delta x, approaches 0 of f of x plus delta x minus f of x over delta x if f of x equals square root of x minus 5. So, very first thing, I think a lot of you kind of thrown off by that delta x thing. So here's what I'll do. I'm going to tell you guys to let delta x equal to h. Any other letter will probably be helpful to see in this case. So that's the first part. All right. So that takes care of that. All right. So now, all right. What do we do now? Well, it just means in this case, well, that means a limit as h approaches 0 of f of x plus h minus f of x all over h. And you might have seen this when you did pre-calc and all. So we're going to plug in, for the first part, x plus h into our function f of x. And so therefore f of x plus h is really going to be the square root of x plus h minus 5. All right? And then f of x is just the square root of x minus 5. So when we set up our limit here, is the limit as h approaches 0 of the square root of x plus h minus 5 minus square root of x minus 5 all over h. Okay, so now we distribute the -1 here, right? Because, we have this root -1. This becomes negative square root of x, and this becomes plus 5, all right? And so now the -5 and the positive 5 cancel out. And so it moves down a little bit here. So now this becomes the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Now, if we were plugging in 0 for now, we would get a 0 over 0 situation. So we're going to simplify this using a technique we had learned before, especially when we have a binomial involving irrational radicals in this case. So we're going to multiply the top and the bottom by the conjugate. And the conjugate in this case is going to be square root of x plus h plus square root of x. And again, the value doesn't change, so we have to worry about that. Now, to make things easier for ourselves, we're just going to multiply the conjugates together. And in this case, conjugates we multiply is really the first one squared minus the second one squared, because the middle terms cancel her out. So we're going to get on the very top of the numerator, we're going to get this x plus h minus x. Okay? Because in this case, this becomes, we get, in this case, the square root of x plus h times square root of x plus h. All right? And then plus square root of x times square root of x plus h minus square root of x times square root of x plus h minus the square root of x times square root of x. And that's how we get this here, because in this case, these two terms cancel out, and then you get, square root of x plus h plus square root of x plus h is x plus h, square root of x plus square root of x is x. Our denominator is still going to be h times the square root of x plus h plus square root of x. Kind of messy. Sorry about that. No. So I'll just rewrite here another row. Extend this page. Oops. All right. So now we have the limits as h approaches 0 of x plus h minus x all over h times the square root of x plus h plus square root of x. Sorry, my handwriting's bad. So now your numerator we'll see in this case x plus negative x cancel out. And so now we just have the limit as h approaches 0. You keep asking, some people ask me, why do you keep writing that? Because we want to remind us a limit, okay? Because that's the important part we have here, of h all over h times the square root of x plus h plus the square root of x. And so before we plug in 0 now, we still have 0 over 0. But we can do is we can simplify the h's out. So we have 1 and 1. And so at this point, we can plug in the 0. So we have 1 over the square root of x plus 0 plus the square root of x, which means the limit will be, in this case, 1 over 2 square root of x. Okay? For those wondering, okay, well, what about the delta x? Well, because the delta x really was the same thing as h approaches 0, it, we took care of that by simplifying out using our technique here of, we get that factor that causes us to give us a 0 over 0, right? That's the whole plan in all this, is try to make sure that we can work this out. And again, it's not like we can divide by 0. We can, but the idea is that using this technique of a limit here as we approach 0, as delta x or h approaches 0, it's almost like getting close to divide by 0. What results do we get though? Okay. All right, everybody. Hope this was helpful. Okay. And I know we did this in class, but just in case you guys, because you guys asked for it, no, I don't mind doing a video, even though it's early in the morning. But that's okay. It just means that now I have to make breakfast. All right, everybody. Thanks for watching. Thanks for requesting. Again, if you are not subscribed to the channel, please subscribe to the channel and all, because now we've hit the magic number 200, and I'm giving away a Funko Pop, the Lion Friends Brown Bear Funko Pop and all, for everyone who's subscribed. And so if you already subscribed, you're already entered in, and then of course every comment in the comment section below you make will add, in this case, add another entry into the raffle. In this case, so it'll be just a nightmare. But I'll be doing all these things and try to calculate everything. The giveaway will close around. We're probably near the end of the year. All right, so just definitely want to make sure I get as many entries as possible, which of course is a lot more work for me, but that's okay because you guys are worth it though. All right, everybody. Also, if you have more questions to go over, please let me know. All right, I'll definitely do videos with them and all. Thanks so much for watching, everybody. Thanks so much and share this video and give it a like as well too. That'd be really appreciated and all. So this is not only for my BC class, but really it's for all calc students and all. So if you have friends who are like having trouble with this, definitely share. Okay, bye. Thanks so much for watching. Take care. Be safe.